Hi everyone, this is MathsForUni. Today I'll be discussing Part 2 of Step 2 2019 Q1. If you enjoyed this content, then please consider liking and subscribing, as well as checking out both of our Udemy courses. The links are in the description. This part of the question says, the curve C has equation y equals a x minus p, x minus q, x minus r, where p, q, and r are constants with p strictly less than q, strictly less than r, and a is a non-zero constant. The tangent to C at the point with x equals a, where a is not equal to p, passes through the point P0. Show that 2a is equal to q plus r and find an expression for the gradient of this tangent in terms of a, q, and r. So for starters, to reiterate, we have this curve C, which is given by the equation y equals a, x minus p, x minus q, x minus r, and we have that p is less than q, which is less than r, and a is a non-zero constant. Now, in the previous part of the question, we looked more generally at curves of the form y equals f of x, where f of x is x minus p times some polynomial g of x. And we notice that the curve we have above is of that form, with g of x being the constant a, and then we have the x minus q and the x minus r. In the question, in this part, we have been told that this tangent to the curve C at the point x equals a, where a is not equal to p, passes through the point P0. This is significant because in the previous part of the question, we looked at situations more generally where we have a tangent passing through the point P0 when we have equations of this form. We showed that this occurs if and only if g prime of a is equal to 0. So, because we've been told that the tangent passes through the point P0, we now know that it must be the case that g prime of a is equal to 0. So, let's calculate what g prime of x actually is to begin with, and we have that g prime of x using the product rule is a, and then we have x minus r by differentiating the first factor, and then x minus q by differentiating the second. If we collect the x's together, we have 2x minus q plus r. Since we have that g prime of a is equal to 0, putting a in here gives us that a times 2 small a minus q plus r is equal to 0. We were told that capital A is a non-zero constant, and so therefore this is equal to 0, which tells us that 2a is equal to q plus r, as we were required to show. The last bit of this part asks us to find an expression for the gradient of this tangent in terms of a, q, and r. Recall from the previous part of the question, from the previous video that we looked at, the gradient of this tangent is equal to f prime of a, and we used the product rule with the definition of f of x to expand f prime of a as g of a plus a minus p times g prime of a. However, in this situation, we have that g prime of a is equal to 0 because we have this condition here. And so this term is equal to 0, and we just have g of a. Looking at the definition of g of x, which is this thing here, this is equal to capital A times a minus q times a minus r. Now, the question wants us to find an expression for this gradient in terms of capital A, Q, and R. And so we need to eliminate the small a. Luckily, we have an equation here that does just that. And so if we apply that, we get capital A, and then we have Q plus R over 2 for A, which you can put here and here. Then Q plus R over 2 minus Q, we can look at Q over 2 minus Q and put those together, and we will have A R minus Q over 2, and similarly for this one here by symmetry with Q and R, we get Q minus R over 2. Bringing out the factors of 2 and a minus sign, we get minus a quarter A, and then say R minus Q all squared. And we write it in this way because we have that Q is strictly less than R, so R minus Q is positive. But that is just a convention. It doesn't really matter because we have a square, and so either way it's the same. If you found this content helpful, then please consider liking and subscribing, as well as checking out both of our Udemy courses, of which the links are in the description. Please be sure to check out the final part of this question in the following video. Thanks for watching, and goodbye for now.